Hello and welcome to a new video on IGCSE Classified Physics Paper 2. In this video, we shall be discussing diodes and rectifiers. We'll begin with conceptual questions. Which electrical symbol represents a diode? So a diode basically is a device that allows current to pass in one direction, but blocks it if it passes in the other direction. So this, of course, is the diagram of the diode, and it sort of represents what the diode does. Here, if the current goes from left to right, it's allowed. If it goes from right to left, it's blocked. And you can see that there is like sort of like a closed door kind of thing where the arrow is pointing. There is something that blocks the current from moving. Anyway, B here would be the correct choice. A diode is used as a rectifier. What is the purpose of a rectifier? So a rectifier basically changes an alternating current into a direct current. This is the purpose of a rectifier. How does it do that? By doing what a diode does, just in a more complicated way. It allows the current to pass when it goes from a certain direction, but stops it where it flows from the opposite direction. So B here is the correct answer. An alternating current power supply is connected in series with a resistor and a diode, which graph shows how the voltage V across the resistor varies with time. So A here, of course, A is wrong, but like here, A is the graph of a regular alternating current. What does a diode do? When the current flows, let's say, in the positive direction, it's allowed. But when it flows in the negative direction, it is stopped. And then when it flows in the positive, it's allowed. When it flows in the negative, it is stopped, and so on and so forth. So C is actually the correct answer. B and D, of course, are wrong. However, just FYI, if you get a graph that looks like this, excuse me. So if you get a graph that basically looks like this would also be correct. So basically the opposite of C would also be correct. So just 0 and then negative and then 0 and then negative and then 0. This would have been also correct. But either this part only or this part only, because as you can see together, they just give you back option A. So like we said, option A here, this is the alternating current. Option C is what a diode does to the alternating current. A student connects the circuit shown, which graph shows the variation with time of the current in the resistor. This is exactly the same as what we said last time. This is what an alternating current looks like. But of course, after the diode, it becomes like this. So the correct choice here is choice B. The circuit diagram shows an AC power supply connected to two diodes and a resistor. The graph shows the current from the supply. Which graph shows the current in diode X? So these two diodes together actually cancel the effect of one diode, because when the current is flowing in this direction, it will flow through here and it will continue normally throughout the circuit. And if the current is flowing in the opposite direction, it will just flow normally like this, come here, and then it will not be able to pass through Y, but it will be able to pass through X. So it's as if nothing has happened. However, if you're only looking at diode X, so this will just be similar to the previous questions where you have one cycle of current and then 0, and then one cycle of current and then 0, and so on and so forth. So C here is also the correct answer. The diagram shows a circuit component. What is it used for? Of course, this is the diagram of a diode, and this allows the current in one direction only. So A is the correct answer. Diagram 1 shows a circuit containing an AC power supply, an unknown component X, and a fixed resistor. The graph in diagram 2 shows how the potential difference across the resistor varies with time. What is component X? Of course, we've done this a number of times in this video. So this is the graph of a diode. So C would be the correct answer here. Now let's move on to more analytical questions. The circuit diagram shows a circuit with an AC supply. This is not really very analytical. This should have gone on with the previous section, but anyway, which diagram shows how the current varies with time? Of course, we said this before. This is graph B. I apologize for that. But B here is the correct answer. Yes, starting here, this is where analytical questions are supposed to start. 4 circuits, each contain a 6-volt battery, a diode, an ammeter, and a lamp. None of the components is faulty. Which circuit shows a possible ammeter reading? So now we need to sort of draw and figure out what happens. So let's start with circuit A. This is a DC, remember? So the conventional current flows this way, and then this way, and then this way, and then this way. So this circuit works because the current is flowing in the direction that the diode allows. So we do expect to have a reading here of something other than 0. So for now, I believe A is correct. Let's move on to B, C, and D and see why they do not work. For B, the current flows in this direction, and the diode allows it to flow, so it continues. So it moves through the ammeter, and the ammeter should be reading something other than 0. So the fact that the ammeter is reading 0 tells me that this is incorrect. For C, the current moves in this direction, but the diode blocks it immediately. So we expect here the reading to be 0, not 1. So therefore, this is wrong. In D, same idea, the current is blocked by the diode, so we would have expected here to read 0. So therefore, D is wrong as well, and the correct choice, like we said, is choice A. The lamps, the diodes, and the batteries in the circuits are identical. In which circuit does the ammeter give the greatest reading? So let's again analyze the path of the current. Current goes this way, and the ammeter reads the current, and then it flows in here. It's allowed to flow, and it's allowed to flow. So this circuit basically looks like a circuit that does not have diodes. It's as if we do not have diodes in choice A. Okay, what about choice B? So the current will flow here in this direction. It will not be able to flow here because the diode is blocking it. So it's as if we can cancel out this branch altogether. But if it flows in this direction, it can go back. So in this case, we have a circuit that looks like this. This is choice B. If you want to redraw choice A as well, we can. It's going to look like this. Without the diodes, it's going to look just like this. What about choice C? Well, choice C, the current will flow in this direction, will flow here, and it's allowed to flow and go back. But if it tries to flow here, it is blocked by the diode. So we can basically remove this part from the circuit. And the circuit now looks like this. And for choice D, the current starts to move from the positive terminal, the conventional current, of course, and it's blocked. So basically, it does not move at all. It cannot pass the very beginning of the circuit. So basically, choice D has no current flowing in whatsoever. So which of the first 3 circuits that I drew above would give the largest ammeter reading? Of course, if you remember series and parallel transmissions, remember all the circuits have the same number of batteries, right? The circuits are identical. So let's assume that we have like 6 volts here, for example. We have 6 volts. Let's assume this is 6 volts as well. And let's assume that this is 6 volts as well. And let's assume, for example, that the lamps are all 3 ohms in resistance. For example. So what is the current in each case? Let's start with B and C because they're simpler. In B, the current is basically, of course, we remember that V equals IR, right? And the voltage is 6 and the resistance is 3. So 6 divided by 3, so the current equals to 2. In C as well, the current is equal to 2. Same idea, same circuit, pretty much. In A, however, the current here is 2, and the current here as well is 2. So the total current flowing in that would branch and give me 2 here and 2 there has to be 4. So the current in this ammeter is 4. So therefore, the circuit that has the greatest ammeter reading would be circuit A. This is the scientific way of doing it. The not so scientific way is basically just figuring out that B and C are identical. So neither of them can be correct, because if B is correct, then why isn't C correct? If C is correct, then why isn't B correct? So you automatically just cross them out and you choose A. This is like the easy, fast way of doing it. So anyway, A is the correct choice here. The circuit diagram shows a power supply connected to some circuit components. In the diagram, P and Q are the terminals of the DC power supply. Under which circumstances does the ammeter show a reading other than 0? So let's figure out the two alternatives. If P were positive, Q were negative, the current would flow in this direction, and then it can actually flow in both directions here because the diode will allow the current to go through. And then it would converge and go back to Q. So for the case where P is positive and Q is negative, the ammeter shows a non-zero reading. There is actual current in the circuit. Let's try the other way around. Let's try Q positive and P negative. So in this case, the conventional current would flow in this direction and then through here. And then it could flow in this direction, but if it tries to flow through here, it is blocked by the diode. So it does not flow in this branch. So the ammeter would show 0 reading. Therefore, this is incorrect. So based on these two scenarios, we can choose that only when P is positive does the ammeter show a non-zero reading. So the correct choice here would be choice D. The circuit diagram shows a DC power supply connected to 2 resistors R1, R2, and 4 diodes. Which statement is correct? Again, let's try to trace the path of the current. The current flows from here to there. Now it has two options, either to move in this direction or to move in this direction. But here the diode is blocking, so it cannot move in this direction. So we disregard this part. Now it will continue moving like this, and then it gets two other options, either to move in this direction or in this direction. But the diode here is blocking, so we cannot move through this. And we're back here. Then we can only move through this diode in this direction here and back through the resistor. So tracing the path of the current again, there is a viable path. I'll just go through it again with another color, with green. So this is the path of the current. So does it pass through R1 and R2? Yes, it does. So there is a current in R1 and the current in R2. There is a viable path that goes through both resistors. So A would be the correct answer. The 4 circuits shown all include an AC power supply, 2 diodes, and a lamp. In which circuit is there a rectified current in the lamp? Of course, again, the easy way of figuring this out without too much analysis is C and D are both wrong because they look exactly the same. The only difference is that the diodes are both looking up and the diodes are both looking down. But this doesn't really matter because this is an alternating current. So it will once move like this and be blocked, and the other time it will move like this and be blocked. So in case of C, it will always be blocked in a sense. But in case of D, it will always be allowed. So if we move like this and we move like this, in both cases, it will be allowed. So it's as if the diodes do not exist. So there is no rectified current. So let's say in C, there is zero current. In D, there is like normal current, normal alternating current. In A, in this direction here, it is blocked, but in the other direction, it works. So this is blocked, but this is working. This is working, I'm sorry. So in A, we have a rectified current because a rectified current means that instead of an alternating current, we have something that looks like a DC current in a sense. So in A, in one cycle, when it goes from the left to the right, it is blocked. But when it goes from the right to the left, it is allowed. So this is a rectified current. But in C, for example, it is blocked both times. So there is zero current. In D, it's allowed always. So there's an alternating current. So these are both, of course, wrong. What about B? When you have two diodes looking like this, they're basically canceling each other out because in one half cycle, it's allowed to go through here. And then in the other half cycle, it's allowed to go through there. So it's as if you have just like a thin piece of wire here. This has the exact same effect as the multiple diodes. So again, B, of course, is wrong. And the correct choice here would be choice A. The four circuits shown each contain four diodes, in which circuit is the direction of the current in the resistor always from the red terminal to the black terminal. So we have to analyze each case and see what happens. Let's start with A. In one cycle, the current will move like this. Again, it comes here, it is blocked by the diode, so it has to move in this direction. And then it tries to move here, but it's blocked, so it moves from red to blue. Okay, and then in the other half cycle, it's going to move in this direction. And then it has the option of moving like this or like this, but the diode here blocks, so it can move through there. And then it attempts to move in this direction, but it cannot because the diode blocks it, so it has to move down through the red term. So A seems to be like a correct answer. Let's try the other ones as well to see whether they would work or not. In this case here, B moves like this, and it's allowed to move from here, but blocked in this direction. And then it tries to go from here, but it's blocked, so it moves in this direction. And in this case, it's black to red, right? So we have a black to red case, and we want it to be always from red to black. So B is wrong without any further analysis. If we can find a way to make the current move from black to red, then the choice is automatically wrong. So in D, let's move through D. The current moves in this direction. It can go in either one of these, but this diode blocks it, so it moves in this direction. Now it can go in this direction and it can go in this direction, no problem. So there is a case where we can go from black to red. So D, of course, is also wrong. In C, let's try to move through here. We are blocked. We move through this. We have either through the red or through the other direction. But then here, you're allowed to go in this direction, and then you're allowed to go also in this direction. So you have no problem going through the black as well. So C is also incorrect. So the only correct choice here would be choice A. And this brings us to the end of our video. I hope this was useful. Thank you for watching.